So before we get started here, let's talk about what factors are in the first place. If we're going to find greatest common factor or greatest common divisor, as if we're going to find the greatest common factor or the greatest common divisor, it would make sense that we know what factor means in the first place. What is a factor? Who could tell me what we spoke of this yesterday between the difference between factors and multiples? What is a factor? Brian, what is it? Well, yeah, we're looking at whole numbers, but that doesn't really give us much of an explanation. They are whole numbers that we're looking at, but what else?
Like a whole number that gets
Total, okay.
one and that's
They are, sure, sure. What? Okay, we could look at it in the lens of division, saying that it's a number that can go into a larger number evenly without a remainder, or we could look at it in terms of multiplication, which is what I prefer we do today, in saying factors are numbers that, when multiplied together, okay, when they're multiplied together, will get you a given number. So here's what I want you to do with your groups, okay, in your group. I want you to come up with all of the numbers that, when multiplied together, will get you 36. Okay? So go ahead and do that right now. Go. Write those down on that whiteboard. Okay, class. Try that again. Class. All right. So I'm gonna open this up right over here, and I'm gonna put the number 36, and I want to get your feedback. The most obvious factor of 36 would be 1 times what? 36. That's probably the most obvious. Now, let's start. Is there anything that we can multiply 2? Let's keep these in order. 2 times what would get us 36? What do you have? What? Yeah, 18. I agree with that. 2 times 18. What would be the next one? What do we have?
three.
3 times 12. Good. What would come next, do we think, Sean? Well, 6 is a factor, but I want one to come before that. What, Lorraine? 4 times 9, that equals 36, right? And then 6 times what, Sean? Times 6. All of these are factors of 36, are they not? Good. Okay, jot those down on your little foldable thing in your notebook. Okay? You put too much glue? All right. Now, with your groups, let's look at 48 and do the same thing. List all of the factors that you can that would get you 48. Go ahead and do that right now. Okay, class. All right, so we're talking 48. Again, the obvious one would be 1 times 48. What would come next, Janaya? 2 times 24. I agree. What would come next? Skylar? 3 times 16. Yeah, no problem. Okay. Zach, what would come next, bud? Yeah, 4 times 12. Is there anything else? What? Yep, 6 times 8. And I think that's going to pretty much do it for us, right? Now, here's what I want us to do. Let's look at these factors. We've got all of the numbers that equal 36 and all of the numbers that equal 48. Are there some common numbers? In other words, are there numbers that are the same in both columns? 1 is one of them. So let's circle 1. Are there any others? Right. Yep. 2s. And then what else? 3s. What else? 4s. 6s. Anything else? 12. Oops, circled 16. Why did I do that? I know that, but we're talking about common ones. Wait, what did I just say? Holy smokes, I needed more seed. Okay, anyway, 16. And we needed to circle this 12 right here. Okay, sorry. Yeah, we're talking about common. No, this one's not. There's not another one here that's common with. So we only circle this one. All right, so we've got 1, 2, 3, 4, 6, and 12. Let's list these, okay? We have common factors include 1, 2, 3, 4, 6, and 12. All right, good. Now the greatest of those numbers would be our greatest common factor. And obviously, what is that? What's our greatest number that's common? Yeah. Oh, no. No, it's not. That is a common factor, but it's not the greatest common. Caesar. Right. 12. 12 is our greatest common factor. Now, this method of getting the greatest common factor is a great method, and it works well if you have smaller numbers to deal with. 36 and 48, those aren't very big, you know. Um, where it can get kind of confusing is if you have a large number, like let's say, you know, 248 or something like that. That's a big number. I have no idea how many factors there are to 248. There might be just a few of them. There might be a half a dozen or more of them, and I need to figure out all of them if I use this method. So that this way can be a little bit um, maybe tricky if you're dealing with larger numbers. Now, what we're going to do is I'm going to teach you a different way of prime factoring, but I want you to write something down. First of all, I want you to write down what I have up here where I said common factors. Let's define what a common factor is. Common factors are factors that are shared between two lists of factors. And it doesn't have to be just two. We could list two or more lists of factors. Common factors are factors that are shared between two lists of factors. And the greatest common factor is the greatest number in a list of common factors. Okay? Let me show you now how we can use what we learned with upside down division. Use that same method we did yesterday when we were prime factoring using this in figuring out greatest common factor. Okay, I want you to do something. In this little space or some space over here, write down 36 and 48. Now, we already know what the greatest common factor is for 36 and 48. It was what? 12. But let's see how we can use upside down division to solve this. Okay, we're going to write out both of these numbers, and then we're going to do this upside down division bracket. Put that all the way underneath, like that. Okay, and now let's think prime numbers. Let's think prime numbers because these are composites. What prime number now, okay? What prime number can go into 36 and 48? What, Logan? Yeah, 3 will, won't it? 3 goes into 36 how many times? 12 times, okay? So just copy down what I've got going on here. And 3 will go into 48. That's right, 16 times. And these are still composite numbers, aren't they? We still have some more factoring to do. So we'll put another division bar underneath. And now we start all over again. What prime number can go into both 12 and 16? What? 2. Very good. 2 goes into 12 6 times, and in the 16, 8 times. All right? Am I done? Janiyah, we still have some work to do. So what do we do next? 2. 2 will go into 6 3 times and into 8 4 times. Okay, now we've got this. Now we've got these two numbers, 3 and 4. And now we got to think, okay, is there another number that can go into both of these other than 1? Ryan, you say yes? Okay, no, there's not. I mean, 1 is the only number that could go into both of those. So if we get to this point, that just simply means, okay, we're done. We're done with this. So here's what I want you to do next. Circle these numbers right here. 3, 2, and 2. And then we're going to multiply those out. 3 times 2 times 2. And what do we get? We get 12. Okay. Again, we get our greatest common factor of 12. This is a really handy method to figure out greatest common factor. And it's virtually foolproof. There's not a lot of room for mistakes when you're doing this. Okay, so let's practice some more of these from our book. You don't need to take out your book. I'll just write them down, and you guys use your whiteboards. Okay, keep your notebooks out. You might need it.